Hey guys, welcome back. First topic we are going to talk about. A lot of this is going to be review. Some of it will be new as we keep going. But the first part, something very important in calculus, is just understanding uh, how radicals work, and radicals tie directly into exponents, and exponents also tie into perfect, you can call them perfect numbers, perfect roots, square roots, cube roots, fourth roots, and so on. So we're going to kind of talk about these three topics, and hopefully this is just some review for you guys that makes sense. Um, but when we're talking about these, I always start with just saying, what is a perfect square? And then we have cubes, we have fourth roots, we have fifth roots. We could go on and on with this list. Um, but essentially, a perfect square is a number times itself. So, like 1 times 1 is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. We could keep going. But these are numbers you want to be very familiar with. Something to take note of in calculus is a lot of this is going to be without a calculator. So you have to be able to work with these numbers fairly quickly and be familiar with them. When we're talking about cubes, we have 1, 8, 27, 64, 125, so on. A cube is a number times itself three times. When we're talking about a fourth root, same idea, 1, 16, 81, that's 3 times 3 times 3 times 3. We could keep going. Fifth roots, 1, 32. Again, and you just want to get as comfortable and familiar with this list of numbers as you can. They're going to pop up a lot. So when we're talking about radicals with these, if you say the square root of 36, we want to make sure hopefully that is 6 in your mind. If you have a radical where it's not a perfect number, so for example, say you had the square root um, of 48, then to break that down and simplify it, you're trying to find the biggest number from this perfect root list that evenly goes into 48. So we would be thinking of that as 16 times 3. And then you could say that this is 4 radical 3, because you could take that square root of 16. Now, why is that important? Well, in calculus, a lot of things you do is multiple choice. So even though the square root of 48 might be correct, it might not be written as that choice, and you need to come up with an equivalent choice. So choice C or whatever would be maybe 4 root 3. So in terms of simplifying radicals, that would be the procedure for that. If you had a cube root, if you had the cube root of 16 and you were trying to simplify that, you would say hopefully that that's really 8 times 2, and then the cube root of 8 is 2. So that's 2 cube root of 2. And you could play that game with all sorts of numbers here. But in terms of how we would compare that to exponents, a very, very important topic for calculus is knowing that if you have something, we'll just say it's a number for right now, and we raise that number to a fraction. I call it P and R. P is the power, R is the root. And we want to make sure that this is something you are super comfortable with when you head into calculus. So for example, if you had 8 to the 2/3 power, okay, there's two ways to attack this. You can say this is 8, and then the power is 2, and the root is 3. And it doesn't particularly matter which order you do it in, but you'll see as you get into bigger numbers that one way stands out. So 8 squared is 64, and the cube root of 64 is 4. If we go the other way, the cube root of 8 is 2, and 2 squared is 4. Now, if we had something with a bigger number, say like 27 to the 2/3 power. When you get this one, I don't think too many people want to do 27 squared and then take the cube root of it. So as a rule of thumb, we're always going to be saying we should do the root first because the cube root of 27 is 3, and then 3 squared, that gives you 9. So by default, we always want to tackle the root first. Okay, so now with that idea in mind, just something else to keep track of, we want to make sense of saying that the 1/2 power, what would that mean for us? That means to take the square root and raise it to the first. But raising something to the first isn't going to change anything. So we just want to make sense in our head that the 1/2 power is the same thing as taking the square root. So if I say 49 to the half power, that is equivalent to saying the square root of 49. So just little ideas like this that we want to make sure you're fluent in and that they make sense when you get to calculus. A lot of the trouble that people have in calculus really has nothing to do with calculus. And it's just little things like this behind the scenes that if you're not fluent in and comfortable in, that it can kind of screw things up for you. So the point, a big point of these videos is just making sense of all the little things that you've been taught over the years and cleaning them up and making sure they make sense before you get into calculus. Okay, another big one that we would want to look at is negative exponents. So if I said 9 to the negative 3/2 power, whenever you have a negative exponent, first off, I tell people just kind of ignore it for a second. Let's just pretend it's not there. If it was 9 to the 3/2 power, this would be the square root of 9, which is 3, and 3 to the third is 27. But if you have a negative exponent, it tells you to take the reciprocal of your answer. We want to turn it upside down. So again, this would have been the square root of 9 is 3, 3 to the third is 27. But a negative exponent tells you to flip your answer, to take the reciprocal of your answer. Okay, so that being said, if we had, let's say 27 over 64, we have a fraction, and we want to raise that fraction to the 2/3 power. In that case, we would raise the top and the bottom to that power. And in this case, this would be the cube root of 27. The cube root of 27 is 3, and then 3 squared would be 9. On the other side, this would be the cube root of 64 is 4, and 4 squared is 16. Okay, what would happen if we had that same question, 27 over 64, but we raised it to the negative 2/3 power? So it's going to be the same situation as what we had up here, but it's going to tell us to flip each one of these. So the 27 to the negative 2/3 answer, when you flip it, it would head downstairs to the denominator, and 64, when you flip that, it would head upstairs, and then that would produce an answer of 16 over 9. Okay. If you have exponents involved in this, let's say, for example, you have 32x to the 10th, and we want to raise that to the 2/5 power. So you kind of want to tackle these individually. The 32 is going to get raised to the 2/5, and so is the x. But now when we go through and we do that, this is a different situation. When you raise a power to a power, the rule for that is if you have x to the a raised to the b, power raised to a power, you multiply them. So that's x to the ab. So in this case over here, this would be 32 to the 2/5, x to the, okay, now we want to multiply these guys. So this is 10 times 2/5. Now, depends how your brain handles that, but we're trying to do 10 times 2/5. So here's how my brain would do that. I would think of 10 as 10 over 1. And when you multiply fractions, you multiply the tops and you multiply the bottoms. So this is really 20 over 5, and 20 over 5 is really 4. Okay, back to our problem now. What is 32 to the 2/5 power? 32 to the 2/5 power says the 5th root of 32 is 2. and then 2 squared is 4. So that's 4x to the fourth. So all of these numbers, these powers, these perfect roots, they pop up a lot in calculus. So the idea of this video, or for studying to get ready for calculus, is you want to be very familiar with this root list that we started with, and you want to know them forwards and backwards. We should be able to quickly say the fifth root of 32 is 2. The fourth root of 81 is 3. Everything on this list, you should be able to do forwards, backwards, upside down, inside out. It will make life way easier, because if that is what your sticking point or your trouble point is in calculus, you might understand the calculus, but you're going to get caught up in some math mistakes behind the scenes. So something that is very, very good to study and know is make sure you know this root list forwards and backwards. Make sure that we understand how exponents work, negative exponents as well. So let's look at a couple more and then we'll wrap this video up. If you had 25x to the 8 over 49y to the negative 6, and we're going to raise all of this to the negative half power. So every single thing in here, we want to raise to the negative 1/2 power. So this is 25 to the negative half, x to the, now what's our rule? Power to power, we multiply. So this is 8 times negative 1/2 is negative 4. This is 49 to the negative half, and then y. Now, what's the story here? A negative times a negative is a positive, so that would be y to the third. Okay, we have all these negative exponents that we need to handle now. So what is our story going to be? 25 to the negative 1/2 power, that would be the square root of, this is all the same thing as just saying the square root of 25, right? Which is 5. But since our exponent is negative, we are going to move it downstairs. Same logic there. We're going to move the 7 upstairs. Okay, and now a negative exponent means to move it, to flip it, to take the reciprocal of it, whichever wording of that you like best. That means we're going to move it downstairs. And when you move it, the power then shifts to be positive. The y is not going to move anywhere because its exponent was not negative. And this would be your final result. So more on that negative exponent stuff. If you want to do a little exercise here that kind of helps explain that, let's pretend we just have 3 letters on top of each other. So let's say that this is -2, 5, -4, -2, 6, 11. And we want to simplify this. To simplify this, we are going to look at each one of these individually. So there's 2 A's on the top, but they're negative, which means I really slide it downstairs. And when I slide it downstairs, it becomes positive. And now I have a total of A to the 7th. Okay, now with these B's, they're both negative, so they both flip. So this is really going to be B to the 4th over B squared. And when that's the case, you can start to cancel. So if you have 4 on the top and 2 on the bottom and you start to cancel, hopefully that makes sense to say that you would be left with B squared on the top. Same logic here, neither of these are moving. We would be left with C to the 5th on the bottom. Okay, so the big takeaways for video 1. You want to make sure that you are familiar with this perfect root list. You are familiar with how to break down a radical. You are familiar with raising something to a fraction, power over root, and we always want to do the root first. And we want to be comfortable with negative exponents. So feel free to watch this video once or twice. You're welcome to look up problems on the internet for exponents and simplifying them. But just in general, this video series, as we release them, it's just all going to be major skills that you guys need to be familiar with that will help you when you get the calc in the fall. So that's it for part 1, guys. Have a good day. We will talk soon.